Today we will see how to evaluate the integral 1 over square root x squared minus 4x plus 29 dx. Please note that this is an extension of our discussion so far this week. At the beginning of this week, we saw how to evaluate the integrals of the form square root ax squared plus bx plus c dx. We have classified this integral right here into 4 cases in that video. And also I have indicated in that video itself that even if we have to evaluate the integrals of the form 1 over square root ax squared plus bx plus c dx, those very same methods that we discussed at the beginning with this integral right here can be applied exactly the same way in order to solve this integral as well. Therefore, during the discussion today, I'm not planning to revisit all those methods. Instead, I'm going to directly jump into this example given here and solve that completely. So the prerequisite expected is you have to know how to evaluate this integral square root ax squared plus bx plus c dx. In case if you do not have the prerequisite, please make sure to go back and watch the video posted in the description down below. Alright, for those who already have the prerequisite, let me start solving the given example. So the problem given here is integrate 1 over square root x squared minus 4x plus 29 dx. Alright, first of all, we can identify whether this integral has a discriminant which is greater than 0, less than 0, or maybe equal to 0. If you carefully do that discriminant analysis, which is b squared minus 4ac, you can see that the discriminant for this problem is actually negative. In addition to that, a, the coefficient of x squared term, is positive for this case. In that combination, we know we have to go for a tangent theta substitution. However, before using any substitution, we have to first complete the square. So let's go ahead and complete the square. This is now equal to integral 1 over, inside square root, we can complete the square as x minus 2 everything squared plus 25, which I will write as 5 squared dx. Now it's very straightforward what the substitution is. We look at this term x minus 2 squared and then write the substitution as x minus 2 equals, and then we look at this term 5 squared and then we write the substitution as 5 tangent theta, and then we need to differentiate both sides of the substitution. Then we get dx being equal to 5 secant squared theta d theta. Now we can go ahead and use the substitution in this integral. This is now equal to integrate 1 over square root x minus 2 is equal to 5 tangent theta. Therefore, x minus 2 squared should be equal to 5 squared tangent squared theta. And then we have plus 5 squared. And then we have a dx term. Dx is equal to 5 secant squared theta d theta. Alright, now we can go ahead and simplify. As you can see that we can factor out a 5 squared from inside of the square root. It will get out of the square root as a 5, and that 5 is on the denominator. That 5 can be cancelled with the 5 on the numerator. So when we do that simplification, we can cancel off these terms with the 5 there, and there will be a 1 right here. And then from the second of the 3 Pythagorean identities from trig, we know that tangent squared theta plus 1 is equal to secant squared theta. Secant squared theta term is inside of the square root. Therefore, it is going to be a first order secant theta in the denominator. And we have a secant second order theta term on the numerator. Therefore, those two can be simplified to become just a secant first order term on the numerator. Therefore, this integral has now become integral first order secant theta d theta. We know that the integral of secant theta is equal to natural logarithm absolute sines secant theta plus tangent theta. This is an indefinite integral, therefore I will also need an arbitrary constant which I will write as k. Well, theta is a variable that we introduced. Therefore, this is not the final answer. We need to keep the final answer in terms of x. Therefore, we will go back and look at the substitution that was used. We used the substitution x minus 2 equals 5 tangent theta. Since x minus 2 is equal to 5 tangent theta, we can subject tangent theta quite easily as x minus 2 divided by 5. Tangent theta term is not the only term that we need. We will also need a secant theta term. Once again, using the second of the three Pythagorean identities from trig, we know that secant squared theta is equal to 1 plus tangent squared theta. From that, we can find the first order secant theta is equal to square root 1 plus tangent squared theta. From that, we can find secant theta as the square root 1 plus tangent theta was shown to be equal to x minus 2 over 5. All of that squared. So once you simplify this, we get secant theta being equal to square root x squared minus 4x plus 29, all of that divided by 5. Now we have both secant theta and tangent theta in terms of the original variable x. So let's go ahead and substitute those things in the final answer. Our final answer should be therefore equal to natural logarithm absolute signs secant theta is equal to square root x squared minus 4x plus 29, all that's divided by 5, plus tangent theta is equal to x minus 2 divided by 5, close absolute signs, and we also have the constant k. Well, this can be simplified some more. That is because we have the same common denominator at these two places. So I will combine them and write it as a single denominator. Now this is equal to natural logarithm absolute signs on the numerator square root x squared minus 4x plus 29 plus x minus 2, all that's divided by 5, close absolute signs, and we have a plus k. This can also be simplified some more. If you remember basic properties of logarithm, I'm going to use the property logarithm base a m divided by n being equal to logarithm base a m minus logarithm base a n. When I apply that property, this answer now becomes natural logarithm absolute signs square root x squared minus 4x plus 29 plus x minus 2 close absolute signs minus natural logarithm 5. We also have a plus k. Now this is equal to natural logarithm absolute signs square root x squared minus 4x plus 29. That part is inside the square root, and that plus x minus 2 close absolute signs. Now I need you to see this part, if necessary, can be written as plus natural logarithm sum c. Well, in that case, I'm going to use another property from logarithm. That is, logarithm based a m times n is equal to logarithm based a m plus logarithm based a n. That means this plus natural logarithm c can be written directly right here as a multiplication with this answer. Therefore, you can keep your final answer this way. Natural logarithm absolute signs square root x squared minus 4x plus 29 plus x minus 2 close absolute signs times c. In case if you do not like to keep the answer that way, feel free to keep your answer also as natural logarithm absolute signs square root x squared minus 4x plus 29 plus x minus 2 close absolute signs and then plus your arbitrary constant. Let me write it as a c star. That's also a final answer accepted. Even if you didn't do the complete simplifications using the properties of logarithm, even by this point you have earned most, if not all, the points of the problem that you are working on. So understanding it up to here is the most important part. Now, if you would like to try a homework question, here is your homework question. Evaluate the integral 1 over square root x squared minus 12x plus 40 dx. Once again, you can see that delta, the discriminant, which is b squared minus 4ac, is going to be negative for this problem. And also, your a is equal to 1, which is greater than 0. Therefore, for this problem also, you will need a tangent theta substitution. That means you can do this question following exact same set of steps discussed in the example of this video. I'm sure you will be able to get the answer for this problem quite easily. I hope you enjoyed this video. Thank you so much.